All right, so we're dealing with quadratic equations, and we want to solve them by quadratic formula. So let's just do a few examples. Let's start with something like this: 3x squared plus 5x minus 8 is equal to 0. And we want to solve using the quadratic formula. Okay. Just like when we were finding the axis of symmetry and the vertex and we were doing all that stuff with the graphs, I want to make a list of what's A, B, and C. What's A for this problem? 3. What's B? C? -8. So those are my A, B, and the C that I'm using in my quadratic formula. And remember, x equals -b plus or minus radical b squared minus 4ac divided by 2 times a. That's our formula. And we're going to plug in everything that we know. We know A, B, and C. So we're going to plug those in. Okay. So B, negative B, if B is 5, negative B would be -5 plus or minus. And then we're going to square B. So 5 squared minus 4 times A is 3. C is -8. Then all of that's going to be divided by 2 times A. I like to work out what's the discriminant kind of on its own and then go from there. I think that helps make it a little simpler to work if you do the discriminant kind of separate. So 5 squared minus 4 times 3 times -8. If I work that out, this is the discriminant. And we'll just abbreviate that disc for discriminant. And so I'm just working out what's going to be under my square root because I'm going to simplify this. So remember, if we're doing square roots, we're simplifying radicals. We'll have to do the factor tree stuff anyway to make this work for us. So that's going to be 25. That's what 5 squared is. And then 4 times 3 is 12 times -8. 12 times -8 be -96. So -96 would be plus 96. Okay. So 25 plus 96 would be 121. 96 and 5 is 101 plus 20. 121. 121. That's our discriminant. That's a positive number. So how many solutions and what kind do I have? 2 real solutions because that's a positive answer. If the discriminant is positive, then it's going to be 2 real solutions. All right. So that simplifies my formula a little bit. And then now I have -5 plus or minus the square root of 121. And then 2 times 3 on the bottom is 6. What's the square root of 121? 11. So I have -5 plus or minus 11 all divided by 6. Well, those are all just regular numbers, right? So I can work those out as 2 problems. So remember we were solving square roots and we'd end up with 2 answers. -5 plus 11 divided by 6. And then -5 minus 11 divided by 6. So -5 plus 11 is 6 over 6. So x equals 1. And then -5 minus 11 would be -16 over 6, which would be x equals, reduce that, be -8 over 3. Two real solutions there using the quadratic formula to solve. The discriminant, I think it's easier just to find it on its own and then plug it into underneath their square root. I usually do that. I usually don't ever write it out like this. I usually will do the discriminant over here on the side and then start with this as my quadratic formula part. All right, let's look at example B. trying to 2x squared minus x equals 7. If I'm going to solve that using the quadratic formula, what does it have to be equal to first? 0. It's the same rules as it was for factoring. If you were going to factor it, you had to get it equal to 0 as well. So let's subtract 7. So it's 2x squared minus x minus 7 equals 0. Okay. Now, got it in the right order. It's in descending order, just like what we've done the last several months. What's A, B, and C? 2, -1, -7 for C. Okay. Let's do the discriminant. -1 squared minus 4 times A times C. That'll be 1 plus 56, 57. So the discriminant is 57. That's not like the square root of 121. You know, we had a nice number. We've got to think, okay, does 57 break down in a factor tree kind of style? 7 plus 5 is 12, so it's divisible by 3. 3 goes into that 19 times, but 19 doesn't break down any. So square root of 57 is not going to break down when I go to do my quadratic formula. X equals -b, so instead of -1, it's going to be +1 plus or minus the square root of 57 over 2 times 2. We're going to split that into 2 answers. This doesn't break down any. It doesn't work out nice like the square root of 121 did. We tried to simplify it with a factor tree, 3 and 19, but 19 doesn't break down any further. We don't get any pairs to simplify that with. So we're gonna just split that into 2 answers. 1 plus the square root of 57 over 4. 1 minus the square root of 57 over 4. And there's our 2 real solutions for this problem. Look at this one. 4x squared equals 7x plus 2. What's it got to be equal to? 0. Is that equal to 0? No. How could we get it equal to 0? I could. I just subtract 4x squared. That'd get a 0 on that side. That's a good idea. That's what I would do. These cancel. There's my 0. -4x squared plus 7x plus 2. So now we have the quadratic in descending order, and it's equal to 0. That's what we need to do quadratic formula. What's A, B, and C? A is -4, 7, and 2. Okay. Let's do our discriminant. 7 squared minus 4 times A times C. 49 plus 16 times 2 would be 32. It'd be 79, 81. And 81 is a good number, right? We can take the square root of 81. And be, 9 times 9 is 9. So the square root of 81 is 9. So we know that's going to help us when we go to do our quadratic formula. X equals -b plus or minus radical b squared minus 4ac divided by 2a. And we know the square root of 81 is 9 over negative 8. So we get two problems. We're going to split that apart. Once we get to this step, we're ready to split it apart. Negative 7 plus 9 over negative 8. Negative 7 minus 9 over negative 8. And simplify each of those. So negative 9 or negative 7 plus 9 would be positive 2 over negative 8, which reduces to negative 1/4. There's one answer. Negative 7 minus 9 would be how much? Negative 16 divided by negative 8. Reduce that. How much is it? It's 2. 2 real solutions. Negative 1/4, positive 2. All right. Not rocket science here. Here's one similar to what we took a quiz on yesterday that we could solve by square roots, but I want to work it with quadratic formula and see how this relates to that. Okay. So, what is it equal to 0 already? Yeah, so it's ready to go. What's A, B, and C? 1, 0, and negative 10. Good. There's not a plain X, so B is 0 in this one. Okay. Discriminant. 0 squared minus 4 times A times C. 0 plus 40 is 40. So the discriminant is 40. So my quadratic formula part, it says negative B. Is there such a thing as negative 0? No, so it's just 0 plus or minus the square root of 40 over 2 times 1. We need to simplify this square root. So how do we simplify the square root of 40? Do the factor tree for 40. 10 and 4 is a good way to start. 5 and 2, 2 and 2. There's a pair of 2's. It's going to come out. So that's going to be x equals 0 plus or minus 2 square root of 10 over 2. Yes, ma'am. All right. Now, since it's 0 on the front, we can drop that and just have plus or minus 2 radical 10 over 2. This is what we're going to do. This is the last example anyway. Okay. Now, this 2 on the bottom and this 2 out front, what can happen to those? They cancel each other out. So it's plus or minus the square root of 10. 2 answers there. The same way you would have solved it yesterday with the quiz we took, you would have done this, x squared equals 10, and then taken the square root and get the same answer. Yes, it's quicker to do that with this problem, but if you forget that you can do that and you just do quadratic formula, you get the exact same answer out of that. So quadratic formula works for solving by square roots. It works for the ones that would factor. It works for the ones that won't factor. It works all the time. So it's a very, very handy tool for solving quadratics. All right. I told Hayden this is the last one. Let's do one more. Let's do one. It's a little bit different. Is that set up and ready to go? Yes, it's equal to 0. It's in descending order, so it's ready to go. So we need A, we need B, and we need C. What's A? C, B, C, 12. Let's find the discriminant. Negative 6 squared, 4 times A times C. Negative 6 squared is 36, and then it's 4 times 1 is 4 times 12 would be 48, but it's a minus 48. What's 36 minus 48? Negative 12. What do we know about a negative discriminant? It's no real solution. We don't even have to do anything else. We're just going to say no. That right there tells us that it's no real solution. That's it. So if we get a negative discriminant, we stop there. We say it's no real solution. You get in Algebra 2, you're going to go further with that. But in Algebra 1, we're going to stop right there.
Well, that's just great.
Yeah, it is. Okay. All right. We've got a handout we're going to do for practice today. I'll give that out after lunch so that the wind doesn't blow them off your desk and they get swept up. Ma'am? Is that what you need?
I need the right there.
That part?
Yeah.
Let me get this stop.